Hello and welcome to another episode of VMOD in the Spotlight. My name is Stace, I'm the technical evangelist at Varnish Software, and this month's VMOD in the Spotlight is the stale VMOD. It's a Varnish Enterprise module that we use to revive and rearm stale objects. Now, before we can talk about the very VMOD that is featured here, we need to talk about stale objects and what they are exactly. Stale objects are expired objects that we still serve past their expiration time, and a very specific implementation that is common in Varnish is called stale while revalidate. Imagine the following situation where a client sends a request to Varnish for content that has expired. Instead of triggering a cache miss, it will still serve the content as a cache hit, knowing that the object was stale. But at the same time, Varnish will perform asynchronous revalidation to get the most up-to-date version and store that version in the cache. In Varnish, the grace value decides how long past the expiration time stale content can be served. Its default value is 10 seconds, but it can be overridden either in VCL, as illustrated here, or by using the following cache control header. So as you can see, the stale while revalidate syntax allows us to set the grace mode, and this will be set to an hour past the expiration time of the object. Although we might believe that the total expiration time of an object is defined by its TTL, in reality in Varnish it's the sum of the TTL, the grace value, and the keep value. And the goal is to keep this greater than 0. If it's equal or lower than 0, then the object is no longer in the cache. The TTL decides how long we serve fresh objects from the cache. The grace value decides how long we serve stale content while asynchronously revalidating. And keep decides how long we keep out of grace objects around in the cache while performing synchronous revalidations. So we've been talking about the TTL, we've been talking about grace, but we haven't put keep under the spotlight. And it's important to know what it does. Keep, as the name indicates, keeps the object around in the cache. So it keeps objects beyond their expiration time. And when keep values are used, meaning that object is already out of grace and expired, it results in a cache miss. But however, the content is still kept around to perform synchronous revalidation. And the reason why it's useful to keep that object around is because we can use headers such as the E tag header and the last modified header to perform conditional requests, which might optimize performance. So to some extent, it makes sense to keep an object around longer than grace and TTL, but by default, the value is set to 0, so if you want to use keep, you need to override the value. At this point in the video, you should be pretty familiar with terms like TTL, grace, keep, and you should understand what stale content is. But everything that I've told you so far assumes that revalidations can take place. So that means the backend is healthy. But what happens if the backend becomes unhealthy and revalidation requests are no longer successful? And that, ladies and gentlemen, is where VMOD stale, subject of this video, comes into play. Whereas grace mode tackles stale while revalidate, VMOD stale tackles stale if error. So that means serving content past its expiration time while the backend is down. And as mentioned in the intro of this video, VMOD stale allows us to revive and rearm objects. And this is how it's done. This VCL code is a perfect example of a stale if error implementation using VMOD stale. It all starts in VCL backend response, where we explicitly set the TTL to 10 seconds, the keep value to an hour, and the grace to a second. With those numbers in mind, we can conclude that the total lifetime of the object is 3,611 seconds. This VCL example also implements a custom subroutine called stale if error that is called from both VCL backend response and VCL backend error. The stale if error subroutine contains conditional logic that is only loaded if the backend response status code is greater or equal than 0 and if a stale object exists. So this means the logic gets called when an error occurs, either because a 500 style error has been returned by the backend or by Varnish itself because it was unable to connect. But the second condition is that there is still a stale object left in the cache. And allow me to refresh your memory and remind you that stale objects have a TTL that are equal or lower than 0, and where the sum of its grace and keep values are greater than 0. When these conditions are met, the stale.revive function, which are part of VMOD stale, are called. The first argument is set to 20 seconds and will override the TTL to 20 seconds. The second argument refers to the grace value, which is set to 10 seconds. And then it's just a matter of calling stale.deliver and returning abandon to override the mechanism and ensure that this revived object is returned. Whereas the original TTL value was 10 seconds, the stale.revive call will override this to 20. And whereas the grace value was originally a second, stale.revive will set this to 10 seconds. However, stale.revive will respect the total object lifetime and will subtract all the overflow from the keep value. So whereas the keep value used to be 3,600, it is now 3,592. However, we can also replace stale.revive with stale.rearm, which will completely override the existing values and will no longer respect the total lifetime of the object. It also has a third argument, because stale.revive ensured that all the overflow went to keep. In this case, we can set both the TTL, the grace value, and the keep value to any value that we want. Throughout the video, you've seen examples where we set the TTL, the grace value, and the keep value in VCL code. And although this is a viable solution where you have strict control in your VCL, it's not really a portable one. And from a developer empowerment point of view, it makes much more sense to set these values in the origin application through conventional cache control headers. And for the TTL and the grace value, this is already possible. In this example, you see that the time to live is set to 20 seconds, which is indicated by the max H syntax, and the grace value is set to 60 seconds through the stale while revalidate syntax. Unfortunately, Varnish doesn't natively support stale if error, but the following VCL code extends this behavior and supports stale if error. We do this by using the header plus VMOD and injecting the value from the stale if error attribute in the cache control header. And this allows us to also use the stale if error syntax in our cache control header. And the value, in this case 3,600 seconds, which is the equivalent of an hour, will be the value of our keep. But remember, if the TTL has expired and the object is out of grace, keep is crucial to ensure that our object is kept around so that VMOD stale can revive or rearm it. And that was VMOD stale, and that was this month's VMOD in the Spotlight. Thank you for watching. I hope you enjoyed it and I hope it provided value. Check us out next month for another VMOD in the Spotlight.